Okay? So, that says, I don't know how to integrate natural log, so he's going to be u. What's left over, so you're looking at the integral of the natural log of x, and then x to the 5th dx. So who gets differentiated? Natural log, and that leaves the rest of this to be integrated. So u is the natural log of x, so the du is 1 over x dx. dv is just x to the 5th dx. So when you integrate both sides, you get v, which is x to the 6th over 6. And now, the way this thing works, we 7 it, so that it's u times v, natural log of x times x to the 6th over 6, minus the integral of v du, which is x to the 6th over 6 times 1 over x dx. dx is the variable of integration. And remember, when we were dealing with this stuff and we were talking about finding, we're going to be doing that again today, finding the area under the curve when we did rectangles, dx was always the base of my rectangle, and then f of x was the height of my rectangle. So anytime you're integrating, there has to be a variable of integration. You're going to find that in 218. It's going to be exceedingly important because you're going to be dealing with functions of more than one variable. If this were an x that says the function I'm integrating has x's. If this were a y, the function I'm integrating should have y's. So you're going to end up with functions in 218 that have both x and y in them already. So when I have a dx, the only variable is x, y would be considered a constant. So that's why you have to have the variable of integration there, because it says what variable am I integrating with respect to. This is a single variable, so we don't care so much. And actually, if I just had a 1 or I had a 2, how do I know when I go back up and I integrate a 2, is it going to be a 2x or a 2y or a 2z? This tells me it would be a 2x, the variable of integration. And that's where it plays a more important part. So here, I want to simplify this. I do so, this x cancels out with one of those, leaving me with a 5. So I have the natural log of x, x to the 6th over 6, minus the integral of 1/6 x to the 5th dx. This is where kind of sketching things out, you kind of then begin to fall all over yourself because you've got fractions that basically are going to just kind of go by the wayside and you lose them. So it's much more precise and organized, let's put it that way. So I now integrate that. That's just anti-power rule. So this would be the natural log of x, x to the 6th over 6 minus 1/6, that's the constant. Antiderivative of x to the 5th is x to the 6th over 6. Now I'm finished. There's nothing else I need to do, plus c. So if you want to clean it up a little bit, I usually like to have this thing in front. And then 6 times 6 is 36. Or somewhere along the way. This is perfectly fine. There's nothing wrong with that. Depends upon what you're going to do with it. Any questions? This is, remember, this is the case. We have two cases in integration by parts. This is the case of the disappearing function. You have to kill the function. Now, if I turn the page to the other side, and I look at this guy, this is x e to the 5x, I can integrate e to the 5x fairly easily. It will never go away. I can differentiate to my heart's content. E will always be there. I can integrate to my heart's content. E will always be there. I need to get rid of the x. So that's the thing I'm going to kill. So this is a guy, I'm going to kill this guy. So I play assassin, I'm going to kill him. The only way I can kill him is to differentiate him. So that means as I want to look at the integral of x, e to the 5x dx, this guy has to be u, and this guy has to be dv. So that u is equal to x, du is equal to dx, dv is e to the 5x dx. And now when I integrate both sides, the integral of dv is v. That's my variable. V is my variable because dv tells me that's what my variable is. And then the integral of e to the 5x, this is why they gave you as a basic, not e to the x, but e to the kx. So it says, what is the integral of e to the kx? It's 1 over k, because k is 5, e to the k, which is 5x. And now you 7 it. So it's u times v, x times 1/5 e to the 5x minus the integral of v du, which is 1/5 e to the 5x, and then dx. And I can integrate that. I've already done it once. So this is 1/5 x. I just rewrite it because that's the way I'm used to seeing it, a creature of habit. 1/5, that's the constant, times the integral of e to the 5x, that's e to the kx. So it's e to the kx times 1 over k plus c, because there's nothing else left. So this is 1 over 5x e to the 5x minus 1 over 25 e to the 5x plus c. Any questions? Yes?
I think I'm just gonna have a hard time like figuring out like the top, like deciding what to kill. So like you don't do E because of why again?
Because it never goes away. If you differentiate him, you still have e. Because the derivative of e to the x is e to the x. If you integrate him, you still have e. Because the integral of e to the x is e to the x. You can't kill him. Now you can kill natural log, and you can kill a variable to a power. You can't kill e. So you're going to rarely find that he's the guy you're going to have to kill because you can't kill him.